Hello friends, myself Avisake, first year undergraduate at Jadavpur University, and welcome to my channel. So it's the second video on the series of JEE Main previous year's problem series, and the topic is quadratic equation. So let's come to the questions. The first question is, alpha beta belongs to C, that means complex number, are the distinct roots of the equation x square minus x plus 1 equals to 0. Then alpha raised to the power 101 plus beta raised to the power 107 is equals to 2, minus 1, 0 and 1. So it was asked in JEE Main 2018. So let us solve. If we solve x square minus x plus 1 equals to 0, we will get x equals to 1 plus minus 3 root 3 iota by 2 by Sridharacharya's method. So we can say that x equals to minus omega square. You can check it. So I can say alpha equals to minus omega and beta equals to minus omega square. So if I add minus omega to the power 101 plus minus omega square to the power 107, I will get, it is minus times omega square plus omega, as omega cube equals to 1. So it will equals to minus times minus 1 equals to 1, as we all know 1 plus omega square equals to 0. So omega plus omega square equals to minus 1, and put it here and you will get 1. So correct answer is option number D. Next question is, let S equals to x belongs to R such that x greater than 0, and this equation, so then S contains exactly 4 elements, is an empty set, contains exactly 1 element, contains exactly 2 elements. It was asked in 2018. So if I want to solve it, let's come to the equation 2 modulus of under root x minus 3 plus under root x times under root x minus 6 plus 6 equals to 0. If you solve it, you will get 2 modulus of under root x minus 3 plus under root x minus 3 whole square minus 3 equals to 0. So I assume under root x minus 3 equals to t, modulus under root x minus 3 equals to t. So I will get t square plus 2t minus 3 equals to 0. So from here I get t equals to minus 3 and plus 1. So minus 3 is useless as it is modulus and x greater than 0. So under root x minus 3 equals to the modulus equals to 1. So I will get under root x equals to 2 and 4. So x will be 4 and 16. So that there is exactly 2 elements, and the option is D. In the third question, if f(x) is a quadratic expression such that f of 1 plus f of 2 equals to 0 and minus 1 is a root of f(x) equals to 0, then the other root of f(x) equals to 0 is these 4 options, and it was asked in online 2018. So to solve this question, I assume f of x equals to ax square plus bx plus c. We have given that f of 1 plus f of 2 equals to 0. So it will be a plus b plus c plus 4a plus 2b plus c equals to 0, which will be further solved to 5a plus 3b plus 2c equals to 0. In another side, we have given that minus 1 is a root of f(x), so it will come up to f of minus 1 equals to 0. So if I put minus 1 in this equation, I will get a minus b plus c equals to 0. So eliminating c from both two equations, we can get 3a plus 5b equals to 0. So implies b by a equals to minus times 3 by 5. Now if I assume another root to be alpha, then we can say that sum of roots, that means alpha plus another root is minus 1 equals to minus times b by a. It will be minus times b by a. So alpha minus 1 equals to minus times b by a, that means 3 by 5. So alpha will be 1 plus 3 by 5, that means 8 by 5. So another root is 8 by 5 and the answer is D. So D is the correct option. So coming to fourth one, if 2 plus 3 iota is one of the root of the equation 2x cube minus 9x square plus kx minus 13 equals to 0, where k belongs to real number, then the real root of the equation, these four options, and it was asked in online 2015. You can check that. So you should know that this complex root exists in pairs. That means if I assume alpha equals to 2 plus 3 iota, another root will be obviously beta equals to 2 minus 3 iota. So hence it is a cubic equation. I assume the third one to be gamma. So if I apply product of roots, that means alpha, beta and gamma, that will be equals to 13 by 2 from this equation. So it will give us 2 plus 3 iota multiplied by 2 minus 3 iota and gamma equal be 13 by 2. 4 plus 9, that is 13, and 13 times gamma equals to 13 by 2 and the gamma equals to 1 by 2. So you can check that it exists and is equals to 1 by 2. You can check its existence by put gamma equals to 1 by 2 here. So the correct option is option number B. Coming to the fifth question, the number of real solution of the equation x square minus 3 mod x plus 2 equals to 0 is these four options, and it was asked in JMIN 2003. So if I want to solve it, I can do it such a way that x square minus 3 mod x plus 2 equals to 0. I can write it as mod x square minus 3 mod x plus 2 equals to 0. So I can write it as mod x minus 1 multiplied by mod x minus 2 equals to 0. So there will be two cases where mod x equals to 1 and mod x equals to 2. So I can write x equals to plus minus 1, and from here x equals to plus minus 2. So there are total 4 solutions, that is x equals to 1, 2, minus 1, minus 2. So the option is A, correct option. The next question, question number 6, difference between the corresponding roots of x square minus plus ax plus b equals to 0 and x square plus bx equal plus a equals to 0 is same and a not equals to b, then these four options, and it was asked in JMIN 2002. So where the difference of the root is asked, so if I you need to know that if a quadratic equation y equals to ax square plus bx plus c, here if I say the difference of roots, that means mod of alpha minus beta, so it will directly can be obtained by root d upon a, where d is the discriminant. So you can check it and you can use this short trick here. So from here we can say root d, that means a square minus 4b divided by 1 equals to under root of b square minus 4a divided by 1. So I can square this and we can a square minus b square equals to 4 times b minus a. So a plus b times a minus b equals to minus 4 times a minus b. So as a not equals to b, we can eliminate these two and we can reach that a plus b plus 4 equals to 0. and this is option number A. So A is the correct option. Coming to the 7th question, if A, B, C are distinct positive real numbers and A square plus B square plus C square equals to 1, then AB plus BC plus CA is option number A less than 1, option number B equals to 1, option number C greater than 1, and option number D any real number. And it was asked in JEE in 2002. So in this such type of problems, if sum of the squares of number is known and we need product of numbers taken 2 at a time, or need range of the products of numbers taken 2 at a time, we start the squares of the numbers like A plus B plus C whole square equals to A square plus B square plus C square plus 2 times AB plus BC plus CA. So AB plus BC plus CA, that is equals to A plus B plus C whole square minus A square plus B square plus C square divided by 2. So it is equals to A plus B plus C whole square minus 1 by 2. As you can see, A square plus B square plus C square equals to 1. That means the square of A, B and C equals to 1. So obviously A, B and C all are in fraction. So that means A plus B plus C whole square minus 1 divided by 2 will obviously less than 1. So the option will be less than 1. So 7th A option is correct. In the next question, the sum of all the real values of x satisfying the equation x square minus 5x plus 5 raised to the power x square plus 4x minus 60 equals to 1 is A 3, B minus 4, C 6 and D 5. It was asked in JEE in 2018. So in this type of questions where A raised to the power B equals to 1, there are some possibilities such as A equals to 1 and B is a positive real number. B is any positive real number. And the second is A equals to any positive real number and B equals to 0. So first case, I take x square minus 5x plus 5 equals to 1. So I will get x square minus 5x plus 4 equals to 0. I will get x minus 1 multiplied by x minus 4 equals to 0. So from here I can get x equals to 1 and 4. From the second, x square plus 4x minus 60 equals to 0, I will get x plus 10 multiplied by x minus 6 equals to 0. So I will get x equals to minus 10 and x equals to 6. So if I add these 4, I will get summation of x equals to 1 plus 4 minus 10 plus 6. So you can see that it is 1. So there is no other options, no any options which proves that that is 1. So there is another possibility that the base is minus 1 and the power is even. So if you put x equals to 2, you can check that the power is even. And if I assume the base to be minus 1, then it will be x square minus 5x plus 6 equals to 0. So x minus 2 multiplied by x minus 3 equals to 0. So from here I can get x equals to 2 and x equals to 3. So if I add from here, x equals to 2 is selected. So if I add both of these, I will get x equals to minus 10 plus 6 plus 4 plus 1 plus 2. So I will get it is equals to 3. So the option A is correct option. It is a little bit tricky question. You have to solve in this way. In the next question, the equation e raised to the power sin x minus e raised to the power minus sin x minus 4 equals to 0 has exactly 1 real root, exactly 4 real root, infinite number of real root, no real root. It was asked in JMN 2012. So the equation is e raised to the power sin x minus e raised to the power minus sin x. That means 1 upon e raised to the power x minus 4 equals to 0. So if I multiplied it by e raised to the power sin x, I will get e raised to the power sin x whole square minus 4 e raised to the power sin x minus 1 equals to 0. If I assume e raised to the power sin x to be equals to t, so this will convert into t square minus 4t minus 1 equals to 0. From this equation by Siddhartha-Charj's method, I can get t equals to 2 plus minus root 5. Here 2 minus root 5 is rejected as e raised to the power something is a positive quantity. So I will get e raised to the power sin x to be equals to 2 plus root 5. So I can take log in both sides and get ln of sin x. Ln of e raised to the power sin x equals to ln times ln of 2 plus root 5. So sin x will be ln of 2 plus root 5. That is definitely greater than 1, as you can check that ln e equals to 1, and graph of log is an increasing function where at 1 it is 0 and where e it is 1 equals to 1. So as it is, this quantity is greater than 1, it will be greater than 1, which is beyond the range of sin, as sin x, the maximum value of sin x is 1. So there will be no real roots. The option is D. Coming to the last question of this video, if the difference between the roots of the equation x square plus ax plus 1 equals to 0 is less than under root 5, then find the set of possible values of a is a 3 to infinite, b minus 3 to minus infinite to minus 3, c minus 3 to 3, and d minus 3 to infinite. All are open interval, and it was asked in JMN 2007. So I have told previously in this video that difference of the root equals to root d upon a, where d is the discriminant. So from here I can get under root of a square minus 4 divided by 1, that is less than under root 5. So it is, both are positive quantity, so I can square it. So I will get a square minus 4 less than 5. So from here I get a square minus 9 less than 0. So I will get a minus 3 multiplied by a plus 3 is less than 0. From the graphical method or wavy curve method, you can check that a belongs to 3, a belongs between minus 3 and 3. So, and in open interval, so the correct option is C. So thanks for watching. Please subscribe to my channel and best wishes for Diwali. Thank you.